Hello. I was reading your comments for the checking for understanding, and I read some of the emails that you sent me regarding you don't understanding the lesson. I cannot emphasize enough for you to be very specific. When you send me an email and you say, I don't understand anything, it's like, what do you want me to do? If you say anything could be anything from, I don't know how to create histograms. I don't know how to create normal curves. I don't know what do you mean when you say normal distribution, standard deviation, mean. What is the empirical rule? I don't understand how to find the numbers in the normal curve. I don't understand. Like, if you don't are specific enough, I don't know how to help you. I think this is what we're talking about when you just go to your mom and you say, I don't know, pain, right? Like, what do you mean? Is something hurting? Did somebody get sick? Like, you have to be specific, right? So please be specific with your questions. And thank you for those of you who email me and are very specific with your questions. But if you just send me an email and say, I don't understand absolutely anything about the lesson, there are a lot of things in the lesson. There are a lot of activities. You don't understand the do now, the exit ticket, the activity, what specific of the activity, what lesson, what activity you don't understand. So please, if you want me to help you, you have to be specific. Otherwise, I don't know how to help you. So since some of you keep sending me those emails saying, I don't understand anything, I don't know what anything means. So I'm just going to cover what I think might be some of your confusion. If this is not what it is, then I don't know what it is. That's why I'm expecting you to email me or reach out to other teachers if you don't want to email me. But just be specific. That's all I'm asking you. Okay, I will try my best to answer your questions. And hopefully after this video, it's clear some of the concepts. So the first thing is that this is very simple. Okay, maybe it looks very intimidating, but this is actually very simple. You just have to add and subtract. So for example, if it tells you here, identify the mean and the standard deviation for the normal curves, really the only thing you have to do is look at the middle number, and that will be my mean. So for example here, if I ask you what's the mean will be 55. That's it. There's nothing else to it. The mean will be 55. It's the center of the data. And if I ask you what's the standard deviation is the spread of the data. So how far the numbers spread from each other. So it is as simple as just subtracting 55.8 minus 55. Or 55 minus 54.2. And you will be able to see here that the difference is 0.8. So that's the standard deviation. That's it. The standard deviation in this case will be 0.8 inches. And that's it. That's really it. There's really nothing else to it. So let's do other ones. Body temperature in degrees. What is the mean? The mean is 98.3. What's the standard deviation? If you can see here, the standard deviation is going to be consistent, okay, in every single part of the normal curve. So from here to here, you can see that is 0.7. So that's the standard deviation throughout the curve. 0.7. Go ahead and do the next one. So ask yourself, what's the mean? What is the standard deviation? What is the spread of the data? And then let's check your answer. There you go. 6.2 will be the standard deviation, and the mean will be 24.8. So as far as how to create this, that's it. It's really nothing more complicated than that. Okay, you just have to add and subtract. And that's the reason why we say one standard deviation above the mean, one standard deviation below the mean, and then one standard deviation within the mean, right? Like in between the mean. Now, for example, here I'm gonna do it backwards so you have an idea what I'm talking about. Sometimes the curves don't necessarily match the standard deviation, because probably the book chose to have numbers like these ones right here, not necessarily reflecting the standard deviation, but not reflecting anything actually. So for example, if I'm going up by 4, then maybe this one could be 24, then this one could be 28, 32, 36, and so forth. But as long as you know what's the standard deviation, then you know exactly what's the spread of the data. In these examples, they will give you, that they are expecting you to write the standard deviation as it is, okay? But if in case that you get a normal distribution, if they don't give you necessarily the number of the standard deviation, but you have it, you know exactly what it is if they were to ask you what's one standard deviation above the mean. You just have to add it. You just have to add it up, right? Okay, so here if I ask you to fill out this curve with the numbers, then you will put the mean in the middle because that's where it goes, right? Right here, that would be the mean. And then what do you do to find how much is the spread, or what would be one standard deviation above? What operation do you use? Addition, correct. So we say 10.5 plus 2.1. That's if I want to know what's 1 above. What about if I want to know what is 1 below the mean, right? What do? We subtract. So in this case will be 10.5 minus 2.1. And that's how you fill out the rest. That's why we say that is mu plus sigma and mu minus sigma, because that's exactly what you're doing. You're generating these numbers. So let's go ahead and see what we get here. Let's check. So there it is, 10.5, 12.6, and so forth. Go ahead and do in your head number 18. The numbers are not that bad. We don't have any decimals. So go ahead and create the numbers for the mean. The numbers for the curve, giving the mean and the standard deviation. All right, let's check if that's true. There you go. 500, 550, 600, and so forth. So that's how you create a normal distribution in case that's what they're asking you when you're given the mean and the standard deviation.